This is problem 8 from the exam 4 review sheet. The physician ordered platinol, cisplatin, 100 milligrams per square meter IV to infuse over 6 hours, once every 4 weeks, for a patient with a body surface area of 1.7 square meters. Part A says how many milligrams of this drug should the patient receive in each dose. So this particular drug is being administered as a rate of milligrams, 100, per square meter of body surface area of the patient. So that's where we start. We start with the body surface area of the patient, 1.7 square meters. We're going to multiply that by the application rate, which was 100 milligrams for every 1 square meter of body surface area. If we perform this operation, we will know how many milligrams of the drug this patient should receive. The square meters cancel for us, leaving us milligrams of drug. 1.7 times 100, remember the easy way to multiply by 100 is simply to move the decimal point of the other factor 2 places to the right. So if we move this decimal point 2 places to the right, that would give us 170 milligrams as the amount of drug this patient should receive. And that's our answer for Part A. Now, Part B, if the cisplatin label reads 50 milligrams in 1 milliliter, how many milliliters of cisplatin will you need? Well, we need to have the patient receive 170 milligrams. And if 1 milliliter contains 50 milligrams, we can perform this operation to determine how many milliliters of the drug the patient should receive in order to get 170 milligrams of the solid drug. Milligrams will cancel, leaving us milliliters, which is what we wanted to know. 10 can divide into both 50 and 170. And so we end up with a division then of 5 dividing into 17. When we divide 5 into 17, we get 3.4. So in order for the patient to receive 170 milligrams of the drug, we must dispense 3.4 milliliters of the drug. Now, Part C says if the dose of cisplatin is added to 1,000 milliliters of D5 1/2 NS, and the drop factor is 20 drops per milliliter, what is the flow rate in drops per minute? So we want to know how many drops per minute to set our IV equipment so that we can dispense not only the 3.4 milliliters of the drug, but also then 1,000 milliliters of the D5 1/2 NS solution. So that's a total of 1,003.4 milliliters that we are actually infusing. And we are to infuse that over 6 hours' time. So we have a total of 1,003.4 milliliters that need to be infused in 6 hours. We want to know how many drops per minute. So as we've done before, we need to go from hours to minutes. So that's 1 hour is 60 minutes. And we also need to go from milliliters to drops. And that's where the drop factor enters in. The drop factor of our equipment is 20 drops creates a milliliter. So now we will know the flow rate in drops per minute. Well, let's see what we can do to simplify our arithmetic a little bit here. 20 will go into 20 one time. 20 would go into 60 3 times. 3 times 6 is 18. So we have 1,003.4 needing to be divided by 18. So let's see what we can end up with here. 18 will go into 100 5 times. 5 times 8 is 40. 0 carry the 4. 5 and 4 is 9. So that gives a remainder of 10. Bring down the 3. 18 will go into 103. Well, it went into 100 5 times. It also went into 103 5 times. And that was 90. So that gives us a remainder of 13. Bring down the 4. 18 will go into 134. Well, it should probably go in, maybe 7 times. 8 times 7 is 56. Down the 6, carry the 5. 7 and 5 is 12, giving us a remainder of 8. So it's roughly 55.7 drops per minute, which, would we set our equipment at maybe either 55 or 56 drops per minute, depending upon what's the policy. Do we just drop decimal values? Do we round them? But this is approximately the drops per minute that we would need for our flow rate in order to